Welcome back to the second episode of Blind 75. So the next question here is longest substring without repeating characters. Let's try to understand what the problem is. Given a string S, find the length of the longest substring without repeating character. Please don't get confused with substring and subsequence. Substring is contiguous elements. Subsequence could be, like for example, uh, substring of this particular string can be ABC or ABCA or BCB or BCBB. So the characters need to be continuously or contiguously in the string. If it is subsequence, it could be something like, for an example, in this string, a subsequence can be A, C, A, B, B. So it doesn't need to be contiguous. Okay. Okay. So the question actually asks us here to return the longest substring without repeating characters. We are only asked to return the length. So in this one, let's take this example. A, B, C, A, B, C, B, B. So what is the longest substring without repeating characters? So ABC can be 1. So it doesn't repeat any characters. So the length is 3. BCA, again it is not repeating anything. It will still be 3. CAB, again 3. ABC, again 3. BC 2, which is less than 3. So it is still the longest is still 3. And CB, again it is 2. The longest would be still 3. Let's take the next example. S equal to B, 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 B. So what is the length of the longest substring without repeating characters? Since all the characters are same, it will be just 1. Let's take a look at the last example. PWW, KEW. So the longest would be PW, this is 2, WW 1, WK is 2, WKE is 3. Then KEW is again 3. So the longest is going to be 3. Okay, so let's try to understand the brute force solution. So when you hear this problem, what comes into your mind? Ideally, what we would do is generate all the substrings of this particular string and check if they have non-repeating characters in it. If it is, then take the maximum number of characters in that substring, and we keep iterating until we have visited all the substrings of this string S, and then return the result. Okay, so let me try to write this here. So S equal to, I'm so sorry for the handwriting, I'm still getting used to using this Excalibur. So A, B, C, A, B, C, B, B. Okay, so what will we do? So we will take AB, this is a substring, right? Then we'll take ABC, then we'll take ABCA, then we'll take ABCB, CAB, and then, so once that is done, we'll start with BC, BCA, BCAB, like that. So we start with this particular first characters and try all the substring that could get generate from the starting from A, which is index 0, then with B, then with C, then with A, etc. Okay, so how will we check whether a string has whether it has a repeating character or not? So we need a method to do that. So ideally to find the substring, we need to iterate through the array twice, like start with A, then take AB, take ABC, take ABC A, take ABC AB, ABC ABC, ABC ABC B, ABC ABC BB. So this is one iteration. Similarly, iteration of A. Similarly, we have to start with B, BC, BCA, BCB, BCA, BC, BCA, BCB, and so on. So the complexity to create the substring is order of n square. But we need another method to check whether it has any repeating characters or not. So that would be again another, the worst case would be again order of n. So it would be like, for example, let's take the first substring that we make starting from AB. We will call this method. We'll take A, B, C. Then we'll call this method to check whether it has repeated strings or not. Then A, B, C. So ideally we are doing it for all the substrings in here. So the time complexity is order of n cube. Now let's try to implement it to see whether we get an answer or how we can implement this brute force solution. We'll come back and optimize it, of course, but let's start from 0. Okay, so let's see. I'm going to just undo this so that I could come back and optimize it. Okay, how will we do it? So we need two methods, right? I'm going to define a method called contains duplicate. You can name it anything. This is a method which returns true or false for a string. So what would be the input to this particular method? It could be either indices starting from this or ending from this, or we could actually pass the string itself. So in here what I'm going to take is start and end. How am I going to check? So I'm going to use a set data structure in Python. There are equivalents in other languages as well. So I'm going to take a set called cars. So what I'm going to do is I am iterating from start to the end index and see if we have already visited anything which is in the set. That means there are duplicates. In that case, we will return false. Otherwise, we will return true. So let's start iterating. So for I in range of, we have to start with start and n plus 1, because in Python range function doesn't include the end index by default. So we are adding n plus 1 so that it both are kind of inclusive. So for I in range of start to n plus 1, the character is going to be s of I. Okay, and if I'm going to name it car so that we don't get character. Okay, so if car in cars, that means it is already existing, so in that case we will return false, else false. Otherwise we would add it to the character set. So to add it, we would do cars dot add of car. If we have iterated to the entire list and we haven't ever been to this particular condition, that means there are no duplicates. So in that case we will return true. Okay, so we have this particular function to check whether it has duplicate or not. What else do we need? I'm going to define a variable called length, where n is equal to variable called n, and it is the length of s. We need result as well, right? So I'm going to maximum length. I'm going to define it as 0 initially, and then we have to find the substring. How do we find the substring? For I in range of n, for j in range of, we'll start with I value and n. and if contains a duplicate of I comma j. So if it doesn't contain duplicate, then we'll find the max length. How do we find the max length? Max length would be maximum of max length, and what would be the length of the particular substring? It would be j minus I plus 1. How is it? Okay, let's take an example. I'll just write it for your for you to understand. For example, a b c. Say I equal to 0, j is equal to 2. What is the length? So this is j and this is I. So what is the length of the substring? So I'm just saying like this. Okay, this is the string a b c. A is I is 0, j is, so the length is 3. How do we find it out? J minus I, which is 2 plus 1. That is how we figure out. That is how we got this letter here. J minus I plus 1. Okay. So then what do we return? Return max length. Let's try to run it. Okay. Let's see what went wrong. Oh, sorry. So the condition here is if it contains duplicate, we should return true, right? So that's why. Okay. So if car in cars, sorry for the rename. So this function returns true if there is a duplicate. If it doesn't have any duplicate, then it returns false. Okay. So let's rerun this. Okay. So this is satisfied. Let's take a look to see how we can optimize it further. And before that, let's look at the complexity. So time complexity, as I said, is okay, give me a second. Okay, so here this runs through 2 loops, so it is order of n square, and this function also does similar n traversal between the characters from start to end. So the worst case would be n. So time complexity is going to be order of n. And what would be the space complexity? Where do we use space? We use space here to store the characters. What would be the maximum size it could have in character? So it would be order of minimum of n comma m. What is n? N is the number of characters or the length of the S, and M would be the character length. For example, so we have S called A, B, C, D, E. What would be the maximum size it could store? 5, right? Because we need to store A, B, C, D, E. So this is the worst case. What if it is A, B, C, B, A? So at a time in this particular function, what would be the size? It would be maximum 3. So that is m in this case. So the space complexity would be order of minimum of n and m, where n is the length of the string and m is the number of characters in the string. Okay, so let's go back and look how we could optimize it. So we got this, and I also explained the complexities. Okay, so we have this string. Can we optimize it further? How? If you haven't heard it, I urge you to go back and look through the other tutorials to find out how we there is a concept called sliding window. So ideally we have a window, and let me show you. So A and B, AB, this is the substring. So this is the window in our case at the moment. And when we select, say, A, B, C, what is the window size here? It is 3. And in the other substring, it could be A, B, C, A, and so on. So that is what is window. And sliding window, because we use sliding window property and take a decision based on the characters inside the window and move forward. So what would happen in this case? So we can use sliding window here. Okay, so how do we use it? We use this particular I'm just going to take an example and tell you. Say this is start, okay, and I'm going to expand the width size. So A is start, or start is 0, okay, and end is first, initially it is 0, then we move to B. So end is what? End would be, again, end would be 1, and we find the length of the string, like without what you say, duplicate characters, in this case AB. So the size would be 2. Then we move end to 2, so it will be pointing to C. Then it is ABC, so it becomes 3. Then we come here A. So this is already existing in this particular subset, like A, B, C, A. So we kind of move the start index to B. Then we check B, C, A. So the max length is still C, 3, and so and so. That is how the minimum sliding window happens. What is the benefit here? So instead of us going through, start with A, find all the characters, we do it as part of sliding window. So I'll tell you an example here. So start is A and is also A. So we create a map with a count. We are just counting the characters. So A is equal to 1. So the maximum length in this case would be how much? This is 1. Then we move the end. This is S, which is start. This is end. Yeah. Okay. So now it will become A is 1. The count is B is 1. So the maximum length would become 2. Then we move the end here. So it will become C equal to 1, and the length would become 3, because A, B, C are all unique characters in this window. We come here A. So A already exists in the map. That means this is a duplicate value, right? So we move the start to forward and keep it at B. Then we check B, C, A. So the count will still become 1, because we are actually we are considering this and removing this. So it still stays 3, etc. So this is one idea. So there is a catch though. So let's take a example, different example. Say so how do we decide to move this start forward, start index forward? So we have to see if so we are this is where the count is, right? So let me take another example. S equal to C, 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 A, B, C. So initially we'll have C is equal to 1. Then C already exists, so we move forward, right? So start equal to 1, end equal to 1, again C equal to 1. We move forward, it again exists. Then we move forward again. So start equal to 1, start equal to 2, end equal to 2, and so on. So we need to see whether the start element is kind of repeatedly happening. So we can eliminate this checking process by doing it internally in the while loop itself. So we check whether the number of count is, if it is greater than 1, we keep moving the start forward. Let's code this, and maybe you'll get more idea then. Okay, so as we said, what did we want? We wanted a map. I'm going to use a counter, which is a built-in one. You could just use a dictionary as well. From collections, import counter. Okay, so I'm going to define start comma end as 0 and 0. Max length, we need the max length. Max length I'm initializing as 0. I'm going to move the end forward. So while end less than length of s, what do we want to move forward? N plus 1. Okay, so the character is equal to s of end. That means the character at end position, and we are going to update the counter value in end equal to 1. So we are adding this character s of end to the character, and we are going to check. So we need a while loop here to check characters of character. So if it is greater than 1, means that there are duplicates. How do we find out? So if it is greater than 1, we need to move this start plus 1. So keep moving start also forward, and cars of car, let's deduct it as 1. Okay. Okay, so here what we do is, so we have to move the start index forward. So the okay, so what do we want? So we just want to move it to the right. How? So the left side character is equal to s of start, okay, and cars of left side character, we are reducting it as 1, and start also we are incrementing here. Okay, so here what would be the max length? Max length would be max length comma, as we had done earlier, it would be n minus start plus 1, and we can return the max length. Okay, let's try to execute it. Okay, so we have got the answer. What is the time complexity here? So in the worst case, time complexity is going to be order of, so we are iterating it only once, but in the while loop, the worst case it could be order of 2n. So we might have to iterate it multiple. So order of 2n is almost equal to order of n. Then the space complexity is the same, so it is going to be order of minimum of n comma m, where n is the length of the string and m is the number of characters in that string, because we only store the characters. So if there are duplicates, for example a, b, c, so in the case of ABC, we would store a equal to 1, b equal to 1, c equal to 1. What if the value is a, b, a? Then we will store a equal to 2, b equal to 1. So what is the size? It is the minimum of n comma m, where m is the number of characters in the substring. So this is one way. Okay, so let's see if we can optimize it further. Okay, so let me undo it a bit. Okay, how can we optimize it? Okay, what if instead of, so we had a map to store the character along with its count number of characters in that particular substring. What if we store the index instead? What if we store the index instead? So for example, initially the map is going to be a equal to 0. When it moves to AB, b equal, sorry, this is going to be comma, b equal to 1, c equal to 2. Then again a comes, right? A is already here. So a would be what? A would be 3. Okay. Then we will move start as well. Start to B. Then we go to B. B already exists. So B will be 3, 4. B will become 4. We'll move the start as well. So instead of doing the while loop instead, we could use this index value to find the or set the start index. Okay, so okay, let's see how we can do it. Okay, so here is my Leetcode. So we are trying to eliminate this order of 2n here. Okay, so we don't need counter here, so we need a map which stores the index. So it would be character and index. That is how it is going to store. Okay, the everything else remains the same. And okay, so what we are trying to do here is this would change. Okay, so we got this so we are at end index. If s of n in chars, then start would be maximum of chars of n comma start. So this is how we increment I. Max length would be max of max length minus j minus I plus 1. Then we haven't added it, right, in this case, so we'll add it. Chars of s of n would be n plus 1. Okay, so we are storing the value that we use as inclusive. So if there is a and b, so we are storing the value as 2 instead of storing 1. Okay, so let's see, let's run it. Oh, sorry. So we have start and max length and less than. Okay, so if end in characters, start is equal to maximum of characters comma start, okay, so we are trying to extend the range of I comma j here. Key error is 3. So let's try to debug this. Okay, let's print the chars of s of n is equal to n plus 1. Okay, so a is equal to, we are storing the length here, a equal to 1, then b equal to 2, c equal to 3. Then again a comes. S of n is a is in the characters, right? So start is equal to, we are resetting start mp of characters of s of j, sorry, chars of n, comma start, and answer is equal to okay. Okay, so if and in character map, it's a and character map start is equal to max. Oh, okay. Oh, okay. So I did characters of n. So sorry, yeah, it should be s of n. Okay. Yeah, so you can see that a became 1, which is actually length. We are using n plus 1 here. A1, B2, A1, B2, and C3. Then comes A, then it becomes 4. Then we have B here, so it becomes 5, and so on. Okay, so that's it. Let's try to submit and see if it passes all the um, yeah, all the use cases. Okay, there you go. So we have okay, so let's take a look at the last solution, which is this uh, the time complexity and the space complexity. So time complexity in this case is a bit lesser than the previous approach. So the time complexity is order of n because we only iterate it once, and space complexity, in this case this is where we are using the space. The space complexity is same as previous two approaches, which is order of minimum of n comma m, where n is the number of characters in length of the string, and m is number of unique characters in the string. Okay, so yeah, this concludes the second problem in blind 75. I'll be back with the third problem as soon as possible. uh, thank you so much. I'm new to this. I appreciate all the feedbacks, and I'll try to improve. I'm also new to Excalibur, and if you have any tools that can be used interactively similar to Excalibur, which is easier to use, please let me know in the comments. um, thank you so much. See you in another video. Bye.